Alright, so here we are with Unit 11, Lesson number 5. It's just a continuation of Lesson 4, and we're going to do a few more branched alkanes. And what you see here are the rules on how to name these branched alkanes. It's pretty much what I had just mentioned to you. The most important rule is finding the longest possible chain, which is the parent chain. And then naming your branches. And it does get a little bit more complicated because you can have more than one branch and you can have different branches. So what I want to do is go through and show you the couple of branches that you might actually run into. Actually, we can do that as we go along. So, and here are the rules. It's also possible to have more than one of the same branch. So, for example, if you would have two methyl branches, instead of just putting methyl, you would have to put a die in front of that to indicate that you have two methyls. And many times you have to indicate what carbon those methyls are attached to. And as we go through this, I'm going to show you how to do that. Now, a couple of these examples are examples that you're never going to have to run into. So example number 2, that we're just going to cross that one out. I'm just going to work with the ones that you normally would see. So I'm going to do example 1, 4, and 5, and I think there's a 6th one here. So I'm going to cross out numbers 2 and 3 because you're never going to see those on the Regents exam. So let's do number 1. Okay. Oops. So remember the the first thing that you have to do is find, hold on. Alright, so the first thing you want to do is you want to find the parent alkane. So, well, first you want to make sure it's a branched or a straight chain. So let's run through. So if we do the whole finger running thing or the pencil thing, let's see what we can do. Alright, so we have 1, 2, 3, we still haven't gone backwards, 4, 5, 6. Well, now we have 2 routes to take. We can go up or we can go down. Either way, it's going to give us the same number of carbons. So if we go this way, it's 1, 2, 3, 4, 5, 6, and we go 7. We cannot go back this way and back up. So this tells us that our parent chain is this here. And we could very well have gone up and it would still give us the same. So the parent is 1, 2, 3, 4, 5, 6, 7 carbons, which is hept, if you look on your reference tables. And actually, that's the second name. Let me erase that. That's the parent chain, so that goes second. So let's put that here, heptane. Okay. That is here, heptane. So this was our parent chain. I'm just going to circle that. And everything outside of the parent is the branch. And we already know that if a branch has 1 carbon, it's called a methyl. So far this is methyl heptane. And you might say, okay, we're done. That's not so bad. Well, we're kind of not done. And here's why. If you take a look at the parent chain, this methyl group is attached to, if you look in this direction, 1, 2, 3, 4, 5, it's attached to the 6th carbon. If you look in this direction, because you can read it in either direction, it's actually attached to the 2nd carbon. Now, why do we need to worry about that? Well, because here's the possibility. If this methyl group was on this carbon instead of this, it would have a different name. So in many cases, in addition to naming the branch or branches, you also have to indicate what number carbon the branch or branches are attached to in the parent chain. So if we number it in this direction, 1, 2, 3, 4, 5, 6, this methyl would be attached to the 6th carbon. If we number it in this direction, it would be attached to the 2nd carbon. Well, which number do we pick? We're always going to work with the smallest number. So we would put a 2 in front of here. So the whole name for this compound is 2-methylheptane. The heptane is simply the longest chain of carbons. There's a methyl branch, which consists of a carbon and 3 hydrogens, and it's on the 2nd carbon in the parent chain. Okay? I know you're probably saying, what? So what are you talking about? Alright, so let's do the next example. We're going to skip those other 2. Alright, so let's do the same thing here. Let's try the longest continuous chain. And for some reason they've numbered these. It doesn't matter if you start here or here. That's going to be, if I do this whole thing with running my finger along here, the longest chain is going to be 1, 2, 3, 4, 5, 6, 7. And I can't go back this way to get those. That would be going back on my original path. And then this, if I did this, would be the same as this. So it doesn't really matter. I'm actually going to do this as the parent chain. Okay, it's 1, 2, 3, 4, 5, 6, 7. So it is again a heptane. Now my problem is I have a methyl branch here, right? So that's a methyl branch. But now I have a different branch here. This branch has 2 carbons in it. So that's based on, if you look at the reference tables, 2 branches or 2 carbons is based on ethane, and you change the ending to YL. So this is an ethyl branch. So I have to include both of these branches in the name of this compound. Which one goes first? It goes according to alphabetical order. So this would be the first part of the name, and then, oh my goodness, and then the methyl would be the second part. So again, yeah, I know, it's going to be a pain in the neck. So this is the this is the, oh, okay, this is all right. Here's the ethyl, and here's the methyl. So we already know it's based on heptane. This actually gives us more space, heptane. So the ethyl is here. This is an ethyl group. This is a methyl branch. Now I'm going to, if you look at it, you notice that the methyl is attached to the second carbon, and the ethyl is attached to the third carbon. So if you put if you go through with this, I'm going to put this down, and the ethyl has to go first. So it's 3 ethyl. Notice there's a dash. Another dash because I'm putting another branch. 2 methyl heptane. Yeah, what? Yeah, that's the way it is. All right, so let's do this last one. Let me move this up again a little bit. Okay. Alright, and I made it larger on purpose this time. So let's try and find the longest branch. Now this looks really weird. Remember, the H3 just means there's an H here, there's an H here, and there's an H here. I really don't like the way they write this, but same thing here. H, H, and H. Let's find the longest chain. Let's try this way. If I go this way, I start here. 1, 2, 3, 4, 5. If I go up, I can't go back down again. So I'm gonna get, and I can't go this way and then come back up. So I got to continue going to see if I can get a longer chain. Because if I go this way, that gives me 1, 2, 3, 4, 5, 6, 7 carbons. I think I can get more than 7. If I go here, that's 8, that's 9, that's 10. I can't go across and I can't go back. So that is 1, 2, 3, 4, 5, 6, 7. That's 8 carbon chain. Let's see if I went this way. 1, 2, 3, 4, 5, 6, 7, 8. So whether I go up this way or continue, it's going to give me an 8 carbon chain, which is octane. Now I have 3 branches. I have a methyl, and I have 2 ethyl groups. So the methyl group is easy. I have 2 ethyls, and remember, if you have more than one of the same, you have to put a di in front if it's 2 of them. So that's diethyl. How do I number them? Obviously, I don't want to number them in this direction because that's going to give me much bigger numbers than if I numbered them in this direction. So, and the ethyl is going to go first. Now, there's 1 ethyl. If I number them here, that's the first, second, third, fourth carbon, fifth. We don't really need to worry about that. So I have an ethyl on the 3rd carbon and on the 4th carbon. So it's going to be, and this is where it gets tricky, 3, 4 diethyl. Sorry about that. So it's going to be, alright, so it's going to be Hold on. Sorry. Alright, let's keep it this way. Alright, so again, we said we're going to use this as the parent. Okay, and we said that was octane as the parent. So we'll write that down. We have a methyl here and two ethyls. One here, one here. And we said we're going to number it in that direction. So that's the third, that's the fourth carbon. So we have 3, 4 diethyl. And we have a methyl on the fourth carbon, 4 methyl octane. Oh yeah. Crazy, huh? Alright, so let's look at this last one here. It's already getting to be too long here. I'm going to speed this up a little bit. So this is going to be the longest chain. It's 1, 2, 3, 4, 5, 6, 7. Oh boy. Let's try it again before my computer runs out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's going to be the last part. The parent chain is decane. Ew. There is a methyl group here, and an ethyl. So let's number it. It looks like we're going to number it in this direction. That's 1, 2, 3. So we have a methyl on the 4 and the 5. So 4 and the 5 methyl. 4, 5 dimethyl because there's 2 of them. And this is on the 6th, so it's an ethyl. 6 ethyl and decane. I did this fast, so hopefully it's correct. If you think I made a mistake, please let me know. So that's how you do the branched alkanes.